So welcome, aerospace professionals. Thank you for joining us here today at High Purity Systems. Chris and I are going to be talking today about fabricating critical ground support infrastructure for your launch pads. And for those SpaceX folks that are on the call today, just want to congratulate you for a successful launch on Sunday night. Watched the whole thing, and it was extremely exciting to see that get up safely and successfully. So definitely congratulations. I know a lot of hard work went into that from a lot of the team there at SpaceX. So again, I'm Doug Barefoot. Chris and I are with High Purity Systems. I focus on business development with the company, and then also on kind of the technical side of fabricating and welding and any technical issues that we have inside the company. Typically, that's my role. Interesting fact about me, couple of them, I guess. My parents actually started High Purity Systems back in 1985. I know I've aged well, but I ended up coming out of high school, went to college, got my business degree, and then went through the apprenticeship school and was able to get 9 welding certifications through that in different welding processes. So there's my interesting fact. So Chris, you there?
Yep. Hey everybody, my name is Chris Working. I'm a division manager here at High Purity Systems. I've been with our company for over 24 years, and most of my experience with HPS has been as a project manager. I also oversaw our LFF skid and pad project we did at Wallops Island a few years back. As far as interesting facts, I'll share 2 actually. One is that I'm passionate about youth mentoring, and every year for 1 week in the summer, I lead a group of 30 to 40 high school students on a mission trip here in the country, and that's just an extremely rewarding part of my life to work with our youth. And the second interesting fact would be that about 15 years ago, I built a replica of a 65 Shelby Cobra convertible, and I'm very jealous of those of you that are tuning in from possibly Florida or Texas or the West Coast, because I try to drive it year round, but unlike you guys, I have to deal with 30s and 40-degree temperatures in the winter, so I'm jealous of you guys at other locations.
And Chris drives that to the office sometimes, and we can hear him coming down the street. So it's a neat little car.
Yeah. All righty. Next slide. Okay. Quick introduction for HPS and who we are. We were established in 1985, so we are celebrating this year, this past spring, our 35th year in business, which we're extremely excited about. Our company originally was founded to serve a project over at IBM, which is now a Lockheed Martin campus, and they had a very unique clean room piping requirements, and we were able to step in at one of their fabs and help them out. We are also a small woman-owned business, so any commercial requirements that you may have through purchasing, we will qualify for those. Industries served, we serve the aerospace, semiconductor, and biopharmaceutical industry. Some major projects that we have or have done, we partnered with NASA and Orbital Sciences, which is currently Northrop Grumman, and Mars, which is the Mid-Atlantic Regional Spaceport down at Wallops Island, for the construction of the first LFF launch pad in the Mid-Atlantic area. And for that project, we specifically manufactured 14 custom liquid fueling skids and also performed the on-site installation. Customers that we have worked for, SpaceX, of course, Northrop Grumman and Orbital, NASA Goddard, Lockheed Martin, BAE, NRL, and the Department of the Navy, where we're actually currently working on a project now with their ordnance and volatile piping delivery systems. And one last unique note with projects that we've worked on, we are currently working with the DoD and various pharmaceutical companies with our government's Operation Warp Speed program, to helping to develop a vaccine for COVID. So we're very honored to be a part of that program right now. New fabrication facility. So HPS, after 35 years, we have finally outgrew our old building and have a new 30,000 square foot facility here in Virginia. It's giving us more room, more flexibility. We now have permanent workstations, so we can better serve our clients. And then fabrication. Fabrication is our niche. Fabrication reduces overall risk on a project versus on-site manufacturing or construction. The logistics, the safety, and the quality all become less challenging when we're able to use the fabrication shop. We have a better efficiency, which equals for you quicker to deliver. And lastly, we also utilize BIM and CAD for all of our fabrication projects, all the way from the initial design or design assist that we can help you with to our final fabrication drawings and models that we will use.
So some of the things we're going to go over today is what made our first liquid fueling facility project unique. Talk a little bit about the process piping skids that we did there. Give you guys some, just some things to ask your teammates that you're looking to bring on board to help you get some of these things done. Specialty components, lead times. Those are, obviously a big issue in the aerospace world. Your partner, your fabricator's documentation. Obviously a huge thing for you guys to have your documentation right for NASA and anything that goes into outer orbit. Project quality. What does that look like? How does your partner, your fabricator, their ability to make changes, how does that affect you? And then we're going to look at some key considerations for the engineers, and then we'll take some questions at the end. So Chris was on site the majority of the time, so he can chime in at any point on this. I was kind of focused on the fabrication of the skids at this time. But what made this project unique for us? Obviously, it was the first liquid fueling launch pad on the East Coast. Schedule was crazy from bid time to final completion. And obviously, when we started bid documents, engineering was only about 30% complete. This was a huge challenge for us as we were going through, because we started probably building the skids at 50% complete. Obviously, project logistics down on the site itself. I mean, we had anything from, hurricanes coming through. We had flooding, we had freezing, in the wintertime, seawater contamination. Obviously, things start rusting almost as soon as you set them down on the sand down there. Obviously, wind, huge issue. Welding on site. We had to build huts around our welders to keep the wind off of them. And I don't know if any of you were on the call before we actually started, but we were talking about the bugs being an issue down there. I think Chris can talk a little more about the size of the bugs down there. But
so I had no clue when we went to go build a launch pad on the coast there. I thought, well, this is great, building a launch pad on the beach. And I think of the beach as a place where I go with my family and wife to go hang out and enjoy. And I figured out real quick that they have mosquitoes that live in this part of the world on the beach, and they were just enormous, and it was hysterical in some ways. And that we would literally run from our cars to the building we worked in to try to not be eaten up by mosquitoes. So that was kind of an unforeseen condition that who would have thought.
Yeah, I think the welders were joking on site that they would actually come up in the morning to their TIG rigs, and the mosquitoes actually had the TIG torch, and they were carrying it away. They were so big. We'll also get into some documentation later, and we'll show you a little bit about what we do with that. So obviously, as most people on the call know, process piping skids are integral to a liquid fueling facility. For the project that we had down at Wallops, there were obviously numerous skids from watching the launch on Sunday. It was fun to kind of see the pre-launch stages, as the stage 1 and stage 2 got filled with the rocket propellant, the kerosene, so to speak. It's funny, a lot of people, you tell them kerosene is rocket fuel, and they're like, yeah, whatever. But we know this well. We had a bunch, obviously, of liquid oxygen skids, and I know some of the SpaceX folks on the call. You guys actually probably have a little more liquid oxygen skid needs in your service, because you like to subcool the liquid oxygen, 40 degrees less than what others do. So interesting concept there. We had liquid nitrogen skids, some helium skids, which actually the helium skids that we had, we had one that was intensifying the helium up to almost 6,000 PSI. So, which we'll talk about a little bit later. We actually had some 1 inch and a little bit bigger piping where, Chris can testify, they look like gun barrels, not piping, because the 1 inch OD piping, which it was, pipe, so it was 1.315 OD, but it had like a 1/2 inch wall thickness. So the inside of the pipe was only about a 1/2 inch diameter. But we were actually able to mandrel bend a lot of that pipe instead of weld it, which actually made for a much better system from, reducing the number of mechanical joints, reducing the number of weld failures, reducing any internal weld penetration that came into the pipe from reducing the flows. So we were able to bend all this with a mandrel bender and kept the inside smooth and reduced lead time, reduced cost from non-destructive testing, from x-rays and things of that nature. And then we also had a gaseous nitrogen skid. So engineers, obviously, when you're looking to start things, obviously we have to start somewhere with the skids and the piping. And where do you start with? Obviously, we all know, you start with what's flowing through the pipes. What pressures is the fluid or gas that's flowing through the pipes? What flow rates are you requiring for the media? And then what is the final cleanliness needed for the media? A lot of times we're able to ask these questions and assist with the designers with pipe sizing. We can ask some questions and kind of get where they feel like the restrictions are going to be and the flow rates that they're having. And sometimes, people want to upsize the piping, but sometimes you can actually, assist with the flow rates by, having a valve that has a better CV rating or components in it that has a better flow rate. And so along with the project, we made a lot of those recommendations as they went on to the engineers themselves.
Hey, Doug, real quick, just had a question pop in, and I wanted to bring it up to you.
Yep.
Can you tell me a little bit about typical flow rates that you guys have had to design for? And is there any difference in the approach when the flow rate's more or less?
So again, that typically the flow rates are determined obviously by whatever the final piece of equipment or the final the whatever's at the outlet of the skid or the piping, that determines, your flow rate. So the designers are usually telling us what the flow rates need to be. But a lot of times, we'll come back and add in and submit, an RFI or a value engineering kind of, just a comment or something. If we see that you can actually reduce the size of the pipe by changing a component out or something of that nature, where we can say, hey, if we use this type of valve, or we use this flow meter instead of this flow meter where it's not as restrictive and we see there being a benefit there, we'll throw that back to the engineers so that they can then make the final call on, yes, that will work for us, or no, it won't. Sometimes what we suggest, they're like, no, that doesn't work for what we're trying to achieve. And, we'll talk through it. And, sometimes it doesn't work, but there's other times, obviously lead times on some of these components are outrageous. So if we can come up with something, we know the skids needed to be delivered in 2 months, but there's something that has a 10-week lead time, we come back with alternatives for products that will help with the schedule as well as help with the overall final product.
Gotcha. Thanks for that.
So, yeah, definitely. So moving on with specialty components, obviously anybody in the aerospace industry knows that, these things have there's some brutal facts that go along with these specialty components. One is, manufacturers are few and far between, whether it's the final fabricators or, whether it's the manufacturers of individual components, fittings, valves, things like that. So typically these parts are not kept on the shelves. So you can have, you need something, if something is not designed properly or component lists are not made up with kind of a lead time in mind, these things can get out of control quickly. If there's any,
I would say, Doug, we had products that 8 to 16 weeks was a common lead time for a lot of the items. Yeah. And we even had products that had, up to 40 week lead times. So those are all things that really need to be considered early in the project. Is what are those components with long leads? Make sure you reach out to someone and start requesting what those lead times are, because obviously the last thing you want to do is give yourself a 1-year duration for your project and find that some of the components are taking almost a year to arrive, be delivered.
Yeah, definitely. And along with that, if there's ever components that have not been made before, obviously there's from the manufacturers, there's some design time that goes in up front, and they have to create drawings and get drawings signed off on and things like that. And to add to what Chris said, lead times. So when we get started in projects like this from the front, when we say, make sure your fabricator is part of the team. We like to put together, as soon as we get involved, a material component matrix list that kind of, we go out and get lead times on every component that is in each skid. And, we'll put a list together and, we start with the schedule in mind, and we say, okay, schedule doesn't work because there's 2 pieces out here that are 8 weeks past the delivery date of when you guys want to have your skid on site. So that's huge from the beginning to get that list put together and understand where those things are at, because maybe they could have been ordered 8 weeks ahead of time. But obviously the design has to be, to a point to where you're ready to do that. And again, material component procurement, the flexibility in the specs. Sometimes there's not flexibility. As I said before, sometimes we'll offer suggestions and they don't work for what's in need for the final quality or final design. So documentation, we know documentation well. When you start out with your fabricators or your partners that are going to get involved in these types of projects, that would be one of the very first things that you need to nail down as far as whether they understand the documentation. We live in the pharmaceutical and aerospace worlds, and with our doing piping for the warp speed project, which is for the vaccine, obviously the FDA documentation comes into effect, where we have to supply stuff to the FDA to get the final material that's going through the piping to be approved. But aerospace, when you start going into outer orbit, that documentation becomes, and Chris, you'll have to add to this, but I would say it's probably 6 to 10 times as much documentation than what we have to provide for the pharmaceutical world.
Yeah, so, there's no doubt about it. With the pharmaceutical industry, back before we entered aerospace industry, well, we've been in it probably for 30 years, but the past 15 years or so, we really began to understand what your all's requirements were with regards to documentation. And like Doug said, they're probably 5 or 6-fold of what we had experienced previously working with the FDA and the drug manufacturers. So we are aware of what's involved with those processes and the documentation required. And I think we have a slide or 2 later that's going to give you a snapshot of what some of those pieces are.
And so obviously the quality assurance, quality control, the QA/QC involved. Material test reports from everything from the piping systems to the fittings to the valves to down literally to the nuts and bolts that we use. We had to have MTRs for, falls under the Buy American Act stuff. We got very familiar with that. What should you be looking for from your partners as far as documentation goes? Kind of just put a little slide here as far as, what we would provide in our documentation package, kind of as a minimum. You get your welder certifications, our WPS, PQRs, WPQs, your welder certifications. We'd include purchase orders in the final documentation package with packing slips of every receipt of shipment. Then obviously get to your MTRs, as we said, everything from CFCs to calibration certificate reports to all the tools that we're using. And then we have non-conformance logs, anything that came in that wasn't up to spec to what we ordered it to. We've got our isometric drawings, which we'll look at one real quick after this. If there were any bolt torques, things like that, we had a checklist for that. X-ray inspections, the films, the X-ray inspector certificates. We had our QA/QC inspector certificates. Then we did our hydro flushes, the cleaning reports. We had our static delivery pressure test report. We would fill everything to up to a 5 PSI before we shipped it out, and made sure that was in the skid when it arrived at the job site. And then we also included completed photos of the skids before they were shipped out in the package as well. So just a quick drawing. Don't need to go through too much with this. Just a typical isometric drawing. You've got your bill of materials on the right, and then our typical weld logs on the back that show weld number, weld date, welder IDs. Your code, which has to do whether it's a piece of pipe, a flange, a T, a reducer, a valve, and then heat numbers. Obviously, it shows what's being welded to what, which heat number is going to what. Welder initials, date it was inspected, and the inspector initials. And then to the right, whether it was accepted or rejected on the inspection. So we bore scoped these welds as well, which typically I don't know whether your requirement would be that you would need that or not, but ours were fully bore scoped. Keys to project quality. Obviously, your fabricator and your partner on this need to understand the specifications and the QA/QC requirements. That is a huge ordeal. I mean, you need to really dig into that when you're looking for a partner on this, to make sure that people don't think that the aerospace documentation side, especially when you're going to outer orbit, is much different from your standard documentation you provide on some other projects. But dig in, make sure they have the experience. Welder certifications and experience. Don't let them just send you one welder qualification certification and say they've got a team of welders. Make sure that they're familiar with the processes that are going to be used, and that they've welded to these specifications and what non-destructive testing and X-rays that are going to be required. Up-to-date equipment, calibrations, obviously everything that goes through from your torque wrenches to calipers to everything else need to stay calibrated and up to date on their certifications. Dedicated facility to fabricate stainless steel piping and components. Again, that's huge. You can't have cross-contamination in your facilities. If they're when they don't have stainless work, make sure they're not running carbon steel through their stainless fab shops.
Sorry, Doug.
Yeah,
something to consider is, make sure that, your SOPs that you have overlap with the SOPs of the manufacturers and the folks that you choose to partner with on your projects. We're going to take, we have a set of SOPs for aerospace, but we're going to make sure they match up with your SOPs, and we're going to tweak them and make sure they're the right fit for you. Everyone has a little bit different requirements. And that's something that we are familiar with and prepared to do with anyone.
Hey, Doug, I want to ask a question real quick on cross-contamination.
Yeah.
Why is that so important for an aerospace manufacturer to understand in regards to their LFF skid? And then I have another question about lead times, but I'll let you answer that question first. And then also, how do you mitigate for cross-contamination?
That is it's a great question. So, people don't think, again, it's how it goes back to how your vendors ship you the stainless steel. We make sure our vendors aren't shipping stainless steel to us that are on the same racks as a carbon steel. If your partner that's doing this takes their crescent wrench out and grabs a piece of carbon steel and then comes over and grabs the stainless steel pipe on a flange or on a bolt as soon as it gets down to the launch pad on the seawater, as soon as that salt water hits it, you're going to see exactly where that crescent wrench grabbed the stainless steel, because the ferrites will transfer from the carbon steel right to the stainless steel, and basically it makes it a carbon, it gives it a carbon footprint right where it was touched. So it will rust badly anywhere that happens. As well, purging of the piping needs to be done. The oxidation, anywhere that that any of this oxidizes improperly, can become a contamination issue. But yeah, from the cross contamination standpoint, your people just need to have an understanding and know the tools that are being used, that they can't take them from one side to the other. I mean, we've got completely separate facilities for our stainless steel to our carbon steel areas. So and people will try to fight it, but it's a huge ordeal. I mean, especially when you're talking about sea breeze contamination and stuff like that. It will rust and continue to rust from the outside in.
Right. So I got a question from Danielle here, and I wanted to read it off to you. So you talked about being able to reduce lead times on skids by ordering those long lead items early. Those are for those specialty components that you guys have touched on. Also bending some with the mandrel instead of, welding them. Were there any other ways on this project, the Wallops project in particular, you were able to improve lead times, something that space manufacturers attending this can take home with them?
Yeah, good question. I think probably, Chris, one of the biggest things that we did on this was the way we decided to execute the fabrication of the skids. We didn't run them through our fab shop as an assembly line. Once we built that material matrix and saw the lead times that were associated with, and it wasn't just one or two skids, it was probably 13 out of the 14 skids had lead times on material that were, 30 plus weeks out. So what we did was we had a dedicated facility set up to where we were able to set all 14 skids out on the floor at the same time. And we were able to work we were able to work on one until we got to a point where we could stop. And then we were able to work on the next one until we got to a point where we didn't have any more components. So we were able to work on every skid simultaneously and just wait for those last components to be delivered. So I think we came out, Chris, I think it was reduced about 2 months by doing it that way, instead of building it as an assembly line, saying, all right, let's do this skid once we get all the components, and then let's roll to this skid once we get all the components. So it was definitely a huge time savings to do it that way.
Cool. Thanks for that. Thank you, Danielle, for that question.
So I think we're good with this one. So again, I think from a constructability standpoint of your project and of your skids, and from a standpoint from your vendors and your customer and your fabricator, is they need to be solutions providers. So ability to make changes, be able to throw things back and forth. How to, get referrals on a project that is similar to this, before you jump into a project like this with somebody. Are they going to be on the same team as you, or are they going to fight change? Again, I think, really being a solutions provider, and when they see something's going to slip, or, really information in this, I think Chris was one of the major things, was just transparency of information. We need that from our customers, as well as I think our customers need that from us as far as transparency goes. I mean, as soon as we know that something's going to slip, I mean, we need to throw that out and say, hey guys, like, we feel this is going to be a problem. We just wanted to, bring it out there so that we can be ready to act on it if something like this does change.
Yeah, I know from a construction standpoint, I know we've all probably experienced it, but extremely frustrating when you're working with a vendor or a supplier, and you request the product and they say, oh, it's a 16-week lead time. And obviously that's not going to work with your schedule. So your comeback is, well, what can we do to reduce it? The answer is nothing. Okay. Well, we need to figure out something. Can you offer a solution? Nope. 16 weeks. Okay. Can you shuffle anything in your shop? Can you? Nope. And we've all been down that road before. And that's one of those things. Just you got to make sure that we're all in our industry are partnering with the right types of people that are going to come up with an idea of how to do something. If there's let's just say a tea has a 16-week lead time. There's a creative way. We can probably make this tea. We might be able to fabricate this tea, custom machine this tea. There's usually a workaround. So again, that's something that I know we pride ourselves on is we don't like to say no. We like to be transparent, like Doug says. If the news is not good news, we're going to share it, but we're also going to ask you questions on what other options do we have? Could we do this? Could we do that? So that's something, to consider when you're choosing who to partner with.
And to your point, Chris, we did a lot of that with this project. If we'd go back and say, hey, we need this 2-inch by 1/4-inch T. And, they'd come back and say, oh, that's 12-week lead time. And, we'd have to scramble and see how we could kind of, find a way to either put multiple pieces together or, as Chris said, we'd machine a custom part or custom piece here or there. So, yeah, just looking for alternative ways and ways to stay within the schedule is the critical piece when it comes to a project like this.
Yeah. I think one of the things that we do well is we're not only fabricators, we're constructors, and that's the business we're in. So we see a project from a 30,000 foot level, right? So we're not, like as Doug alluded earlier, an assembly line that just said start date, finish date. It is what it is. No, we see the project. We see the project schedule. We know where we fit into that bigger picture, and we understand that. So again, that's just one of those things to consider as well.
So again, key considerations for the engineering team. Going through the project that we had, obviously there were liquid systems, liquid gases in a lot of the pipes. So when you get to the ASME criteria for welding these pieces together, it went from B31.1 to B31.3 severe cyclic criteria. Typically when you go from a B31.1 to a B31.3, that reduces the level of quality of the weld and of the need on the X-ray. But when you change it to B31.3 severe cyclic, it actually makes the X-ray requirements a lot more stringent. There's obviously from, when you take a pipe from atmospheric temperature and introduce liquid to it, obviously you're going from, an ambient temperature to, down to, well below zero and well down into the minus 100s of degrees Fahrenheit, right? So you have a lot of stresses on the pipe. So a bad weld can become bad news very quickly. Pipe bending opportunities instead of welding, as I alluded to earlier a little bit. Doing it the way that we came up with actually had schedule savings, cost savings, much better flows on the piping itself. So when we brought that back, we were actually able to reduce some of the pipe sizes because we didn't have some of those restrictions in the lines that they thought that they were going to have initially. And also for the cost side, we reduced some of the X-ray costs by not welding those joints. I think we were able to reduce probably about 60% of the welds in that system by bending. And schedule, we were able to get the skids done quicker. It was huge, yeah.
Yep.
Understanding how to minimize on-site project risks. So with this, we were actually the contractor on-site as well, but we were pushing as much as we possibly could through our fab shop. I mean, the biggest way to reduce your on-site project risks is to fabricate. Looking for more opportunities to skid piping and to get piping in racks and ship it out as a fabricated item instead of worrying about the conditions on site. So again, with this, we're just saying you need to find a trusted partner to fabricate that can offer, expertise that they've got in the years of doing this to help minimize risk and minimize lead times and improve schedule and hopefully save some costs for you.
Hey, Doug, on that topic from about minimizing on-site project risk, got another question in and wanted to throw it to you because it kind of has something to do with it. You noted earlier that you guys began fabricating at 50% design. What point was that design finalized, and how does work on, a project as delicate as an LFF skid change once you get to a final design?
And Chris, I think you could probably add to this as well. But I mean, I know from the skid standpoint, things were changing up until the end. I think we had shipped our final skids, and then, Chris, you'll have to add to this, but I think when we thought we were done on site, I think we ended up, having a couple weeks to months of change orders in the end to, because design was constantly changing, even after we were done with our initial scope, but things were changing, as we went through it up until literally the last day we were on site.
Yeah, I'd say, with what was planned originally with the on-site installation as far as design goes, we mobilized on site, we began installations, and we would be 90%, 95% done with our installations. And then there would be changes and changes and changes. And I mean, the project itself, they were required, you know what I mean? I mean, the engineering groups, you guys needed to make changes. You saw things, you caught things, especially with LFF. And obviously when this was done, it was a little newer. Now everyone's become a little more dialed in on what's involved. But yeah, I would say when we thought the project was 90% done, it probably was 60 or 70% done. The changes were that significant.
Right.
But again, we were able to do what we could to make those changes on the fly, and able to bring in the project, within the time frame that everyone needed for the first test launch.
How are you guys able to do that? I'm sure the time frame between the completion of the LFF and then the test launch, probably not a lot of time in between then. So what are you guys doing to give yourself the flexibility to get that complete on time?
Truthfully, I think it's a commitment by the company to seeing the project to completion and staffing it appropriately. So, we didn't look at, say, a project like Wallops as, here's my window, we need to be out by a certain date. No, we knew the staffing, full staffing, whether it was the craftsmen or whether it was the project management team. We were in till the end. So we were not, we were engaged. We were engaged to the finish to see the project all the way through. And I think that was a big part, was just that commitment to the team, to everybody out there, that we knew we had to make this happen and we had to do it as a team. And if that required additional resources, whether manpower or working additional hours, that's what we signed up to. And I think that's a big part of why we're able to meet the schedule.
Sure. And I think as well with that, Chris, I think we were invited to the project early enough that, we really felt vested in the project because of the amount of kind of input that we had on it. So, seeing it through was kind of, it wasn't a question, it was a necessity. And you do what you can. Everybody wanted to get to the end, and you could see the end. It was just, let's work together to try to figure out how to get there.
So it's safe to say, like, when you have a project like this that you're doing, key consideration to make for engineering team, just as much as what you guys have listed here, is make sure your contractor has the resources to do those quick turnaround times when those designs come to fruition. Because if they got to put all hands on deck to do that, you want to make sure A, they have the manpower, and B, they have the qualified manpower to do that. And then the other thing is, like, getting your contractor involved early enough that they have design input and they know. Plus, they're also just emotionally vested in the project, so they're going to have the commitment inside of them to finish that out and make sure that they meet that mission.
Yep.
Is that fair to say?
Yep, exactly.
Very much so.
Thanks, guys.
Yeah, definitely. So, thanks for being with us. Do we have any additional questions from anybody out there?
Yes, I got a couple more questions, and anyone wants to drop any more questions, just please drop them in the Q&A or in the chat panel.
And if I could, real quick, just kind of my 30,000 foot summary, for today is, whoever you choose to partner with, make sure you engage and partner with them early in the process. And that means years potentially prior to needing to begin your construction services or your needs, and explain the challenges that you guys have to your suppliers. Tell them what your goals are. That way, people can try to figure out a way to make it happen rather than, again, you just becoming a number and becoming a part of that assembly line process where you get when you get it. Also, the earlier you engage with your partners, it starts the submittal process earlier, right? So we can identify those long lead items, and those can obviously be put on order. Schedule and coordination. Don't look just at with your partners the component level, but look at the 30,000 foot level of what the schedule is and what coordination is going to be required to do that. And does your supplier understand where they're going to fit into this whole puzzle? And of course, without question, does your supplier have experience? Will they deliver? Will they meet the dates? Are they going to be committed to see the project to the end? Do they care, about the project, to be honest? And lastly, will they be flexible in meeting your deliverables? Are they going to be solutions oriented, or are they going to be assembly line oriented to where you get what you get? So, again, just make sure you guys, all of us, you partner with the right supplier. Make sure they understand the manufacturing in the space industry, and how all the pieces of the puzzle come together. So,
yeah, good points, Chris.
Cool. All right, so a couple of questions that got submitted. So you guys said earlier you were able to reduce lead times. Actually, this is a question that we did get. So another question that we got. You said design changed significantly during the project. Was there a lot of leftover materials or components when the project was complete? What did you guys end up doing with that leftover material?
Oh man, Chris, I don't know if you remember, but as things changed with the skids, we had a common list. We had 14 skids going through the shop. So we had a common list of leftover material. And it had valve part numbers. It had valve specs. It had literally everything in this one Excel spreadsheet. And I don't know if you remember till the very end, Chris, but we were using the components on that list on the last change orders that we had as they went along. So we had this long list, and we were trying to make sure that, we didn't need to go buy something that was another, 6, 8, 10, 12 week lead time. So we used a lot of the components that were scrapped or not used on the skids when something got changed to, using it for the change orders on the final on-site install.
Yep. And then also anything that we had left over on the project as well, we typically turned over to the folks down there for the maintenance crews, and that came in handy as well. They wanted an inventory just as much as anybody, because as everyone knows, you don't have 6, 8, 16 weeks at times for some of the parts. So we were able to also turn over a lot of those surplus items. That
entire final list got turned over that we didn't use to them.
Yeah. Again, it's the same kind of risk, right? You need a spare, something breaks. You have the same, it's a specialty component like you guys talked about earlier. So lead time, again, a big problem with that kind of stuff. So just having that leftover material on site and available saves a lot of headache, not just in the lead time, but also frankly, in just sourcing it, right? That stuff's got to be difficult to source for people who aren't experienced doing that, correct?
Yep. And then that's what we found as well was oftentimes, the sourcing process and the procurement process, it was much quicker for our customer to reach out to us directly and have us source items. Their procurement groups, it may have taken them weeks and weeks to have an order placed, where they could get a hold of us via email or on the phone, and we would place orders within a day. So again, that's another option too, is having that.
Yeah.
Very cool. I'm not showing any other questions, but But guys, that was awesome for 45 minutes. That was fantastic. For people who attended, thank you all so much for spending your time with us today. Yes, get this question all the time. We will send you the recording and a copy of the slide deck, not a problem. But that was excellent. If you guys have any questions for Doug or for Chris, here's their email addresses. Here's how to contact High Purity. If you guys have a specialty process piping project that you have in the works or something you want to just ask questions on. Maybe you have an existing one that you have questions on that maybe you need a maintenance, something like that. Reach out, talk to Chris or Doug. They'd be happy to help you out with it. And thanks so much for spending your lunch hour or your afternoon with us, and just have a great rest of your day. Doug,
we didn't put it on here, but it's in the email address. Obviously, if you want to check out our website, it's highpurity.com. And Chris, thanks for hosting with me today.
Yep, it was great. Thank you, everybody.
Thank you all.
Thanks, everybody.